Automerism. Calculation. Full calculation. Automerism. Hello. అంతకుముందు ఇప్పుడే వచ్చా, క్లాస్కి వచ్చాను. అది వ్యాగ్నర్లో వచ్చింది మీరేనా? నేను చూడలేదు అది. బన్నీనేమో అనుకున్నాను. వచ్చి స్నానం చేసి మళ్ళీ వచ్చాను, ఇంకా క్లాస్ స్టార్ట్ అవుతుంది. హలో, అరే వినిపిస్తుంది కదా? రైట్. లాస్ట్ క్లాస్ ఏం చేస్తాం? రైట్. ఈజ్ ఇట్ క్లియర్, రైట్? So volume is clear. Hello. Hello. Children. So the last class we were discussing tautomerism, right? In tautomerism, what we discussed actually? So triad system, phase. In case of triad system, the movement of proton, right, from one place to second place means the hydrogen is moving from 1 to 2 row. Nothing but what? CNH. Okay, like this. So 1 to 2 position, the hydrogen is shifting. We are called as dyad system. In case of triad system, what we did? Triad system, basically the more important thing is keto enol tautomerism. In this case, what exactly happens, Nana? So 1, 2, 3, this hydrogen, the proton is transferring 1 to 3 position, right? So that we are called as CH2 double bond C OH CH3. This is keto form. This is enol form. Keto form. Keto form, enol form. So this we can see in case of nitro compounds also. And double bond O, right? So hydrogen 1 to 3 positions. Here is also possible, right? CH2 double bond N OH like this. Triad system, this is also. Done. So in space isomerism, in space tautomerism, what exactly I told? 15, 17, 19 like that. For example, CH3, CH double bond CH, right? Hello. C double bond O, for example H. 1, 2, 3, 4, fifth position. In this case, exactly what happens? Here, the hydrogen. So we need to see its resonance now. We need to see its resonating structures, like, so this proton is transferring 1 to 5th position. 1 to 5th position. So I told you this CH2 double bond CH, CH double bond COH, H, like that, space. And we discussed this also, even 17, 19 also we discussed. The main important thing is here, for example, this is a compound. In this case, tautomerism is possible or not? Possible. How it is possible? So 1, 2, 3, 4, fifth one. So the compound, in case of tautomerism, what is the condition? The condition should be alpha carbon should be sp3 carbon. This is sp3. So these two hydrogens are there. Two hydrogens. So one hydrogen is like this. So what exactly happens? OH. So this is keto form, this is enol form. For example, in this case, methyl groups which I am adding, in this case, keto enol tautomerism is possible or not? In this case, possible or not? It's not possible. Why it's not possible? Because at 1, 2, 3, 4, fifth position, right, it doesn't have any hydrogens. Right? This is the reason. So this won't undergo tautomerism. And which conditions for the tautomerism I told you? For example, CH2 double bond C, HC double bond O, H. In this case, tautomerism is possible, right? Huh? In this case, tautomerism is not possible because it's sp2, sp2. Hello. In this case, tautomerism is possible. Obviously possible. This is alpha, alpha. Alpha hydrogens are there. It is possible. For example, in this case, tautomerism is possible. In this case, tautomerism is possible. Huh? No, because here is alpha carbon is there. Alpha carbon is there, right? But there is no alpha hydrogens. Done, Rana? Clear, everyone? Hello? Hello? CH3, C double bond O, CH2, CH3. In this case, two tautomers are possible. Yes or no? So we can remove one proton here and we can remove one more proton over here. Right? So which one we need to, if for example left side, if hydrogen we are, right, proton shift is taking place. What exactly happens? CH2 double bond C OH, right? CH2 CH3. This is one possibility. So for example, if we are removing this hydrogen is shifting, is takes place. So now in this case, what exactly happens? CH3 COH double bond CH CH3. Right, both enol forms. This is enol form, this is enol form. Which is major, which is, so here is, we need to see the alkene which is formed. It is having 6 alpha hydrogens, whereas in this case only 2 alpha hydrogens. We know that more alpha hydrogens, compound is more stable, right? Here is 3 and 3. Total 6 alpha hydrogens are possible. Got it, everyone? So this is major. Major, this is minor. Right. So the mechanism which I explained in acidic medium and basic medium. So in basic medium, what I did, in basic medium what I explained, for example, C double bond O, CH3 in basic catalyzed medium. No? The first step, what exactly happens? Base will abstract this proton. No? This base, this abstract this proton. What exactly happens? CH2 negative charge, C double bond O, right? CH3. Now this negative charge is what exactly happens? Resonance takes place. I told you, if the negative charge present on carbon and oxygen, which is more stable, right? Hello. With the negative charge present at carbon or oxygen? Oxygen, because oxygen is more what? Electronegative, right? So now in this case, what exactly happened? Once again, the water is there, right? That donates the proton to this one. It becomes CH2 double bond COH CH3. This is the mechanism, base catalyzed mechanism, which I explained already. So the same in the last class. If you can go to the last video lecture, you can see, because just I am revising because one day gap came na. In case of acid cases, what happens na? Acid catalyzed mechanism. CH3 C double bond O CH3. Now first H plus is coming. Acid catalyzed means acid is coming, H plus is coming. So H plus is attacks at where? Oxygen. So CH3 COH double bond positive charge here, right? Oxygen, at oxygen is more electronegative. If the positive charge is there at oxygen, right, it's not stable. What exactly happens? One of this pi bond is migrating to here. So here what exactly happens? CH3 COH, there is a positive charge now. Now in this case, this one of the H, so coming to here. So CH2 double bond COH CH3. This is acid catalyzed mechanism. This is base catalyzed mechanism. Acid catalyzed mechanism, base catalyzed mechanism. The people who didn't understand, who didn't write, right, who didn't understand, so please let me know. So this is the mechanism in case of base catalyzed, and this is acid catalyzed. And today I'm just going to tell one of the important topic today. So that is keto enol tautomerism. Enol percent of enol percent. When keto percent is more or enol percent is more. So it depends on different conditions. Okay. Hello. In acidic catalysis mechanism, first acid H plus is giving, right? H2SO4 something. For example, we are adding H2SO4. Okay. It's giving H plus. So H plus is coming and attacking where, Nana? Because already oxygen is having 2 lone pairs, right? 2 lone pairs, yes or no? So now it's coming and attacking over here. So then positive charge is present at the oxygen. So then the double bond is there, right? One double bond is migrating to oxygen. So then automatically at carbon will get the positive charge. Yes or no? So when it is positive charge coming, so one of the proton, right? So this H plus already is giving the H catalyzed, right? Acid is giving the H plus, that H plus is taken by the acid once again, right? So this H plus is going back. Okay, here is also last OH we are added, right? Here is also OH is going out. Whatever where catalyst means what? It is right, increasing the rate of reaction. It is increasing the rate of reaction, and it is not as it is. Whatever the H plus we added, the H plus came out. Hello. Here is the OH minus we added, the OH minus came out in the final. So base obstruct the proton, negative charge is coming, so resonance takes place, then proton is given, water is given the proton, automatically we got the product, simple. Right? This mechanism is not that much of important, but we need to know. So sometimes they may ask the questions. But today we'll discuss somewhat important in the keto enol tautomerism only. Which one is more stable? Which one is more percentage? Means keto form or enol form? So that we will discuss. Right. The first condition, percent of enol content. Percent of enol. So for example here, CH3 C double bond O CH3 and CH2 double bond C OH CH3. So this is keto form now. This is enol form. This is in the dynamic equilibrium. So equilibrium is there. So whether this can forward direction is takes place, reaction backward direction is also takes place. Now in the keto enol tautomerism, particularly in different cases, it's keep on changing. In this case, which is more stable, which is more percent is present in the reaction mixture? Let me know. Let me know. Keto form. Okay. Remaining guys. Hello online guys. Hello. Keto form. Yeah. So write it down. Here is one statement. Generally, keto form is more stable here. Keto form is more stable. Generally, in this case, keto form is more stable. Keto form is more stable because this C double bond energy, bond energy of C double bond O. Bond energy of C double bond O is more. Bond energy means for breaking more energy is required, means forward reaction is won't take place. And let me know, right, generally acid base reactions, for example, reactions are moving from strong acid to weak acid, but weak to strong it's not possible, right? Weak to strong. So imagine it is acidic nature is somewhat strong acid, in this case that is weak acid. Weak to strong, is it possible? So reaction rarely occurs. So generally reactions are moving from strong acids to weak acids. Okay, hello. So in this case this is somewhat OH group, right? This is somewhat strong acid. This is somewhat weak acid. So this is also one of the reason. Two reasons. One reason is C double bond O bond energy is more. Second reason, so generally reactions moving from strong to weak, but here is weak to strong is takes place. That is also one of the important reason. Note it down. What do you want exactly? Reactions are moving strong to weak basically, but ikkada idi weak undi, akkada strong undi, right? So forward reaction avutada, backward reaction avutada ekkuva? Hello, forward reaction avutada, backward reaction avutada? రియాక్షన్స్ ఎప్పుడైనా కానీ స్ట్రాంగ్ నుంచి వీక్ పోతాయని చెప్తున్నా, రైట్? ఫార్వర్డ్ రియాక్షన్ అవుతుందా, బ్యాక్వర్డ్ రియాక్షన్ అవుతుందా? బ్యాక్వర్డ్ అవుతుంది. అంటే ఏది ఎక్కువ ఉంటుంది పర్సెంట్, రైట్? మోర్, రైట్? కీటో ఫార్మ్ ఈస్ మోర్ స్టేబుల్ ఇన్ దిస్. Then so now in these two cases, which enol content is more? In these two cases, which enol content? For example, I am writing the enol content here. This is enol form. I am writing the stable form of this. This is two conditions. So comparing, which enol content is more? Enol content, write it down. Enol content directly proportional to stability of enol. Stability of enol. Enol content is directly proportional to stability of enol. In these two enols, which enol is more stable? So based on alkenes, we'll see how many alpha hydrogens here? 3 alpha hydrogens. So alkenes which are having the more alpha hydrogens compound is more stable, whereas in this case how many alpha hydrogens? 6 alpha hydrogens, right? So which is more stable? This is more stable. If they are asking this question, so keto, both are ketones only, which enol content is more means which one? This one. Got it everyone? Any doubt? Hello, అర్థమవుతుందా? ఈ రెండిట్లో ఏది ఈనోల్ కాంటెంట్ దేనికి ఎక్కువ అని క్వశ్చన్ అడుగుతాడు. ఈ రెండిట్లో దేనికి ఎక్కువ అంటే మనం ఏం చేయాలి? ఈనోల్ కాంటెంట్ చూసిన తర్వాత వాటి స్టెబిలిటీ చూడాలి. ఆ స్టెబిలిటీ చూసినప్పుడు ఇక్కడ 6 ఆల్ఫా హైడ్రోజన్స్ ఉన్నాయి. ఆల్ఫా హైడ్రోజన్ అంటే ఏంటి? డబుల్ బాండ్ పక్కనున్న కార్బన్ని ఆల్ఫా కార్బన్ అంటాం నాన్న, రైట్? సో ఈ దీనికి ఏదైతే ఎన్నైతే హైడ్రోజన్స్ ఉన్నాయో దోస్ వేర్ కాల్డ్ యాజ్ ఆల్ఫా హైడ్రోజన్స్. ఇక్కడ 6 ఆల్ఫా హైడ్రోజన్స్ ఉంటాయి, రైట్? కార్బన్ కదా ఇది, 3 బాండ్స్ ఉంటాయి, 1 2 3. సో 6 ఆల్ఫా హైడ్రోజన్స్ ఇక్కడ ఉన్నాయి, 3 ఆల్ఫా hydrogens ఇక్కడ ఉన్నాయి. So basically which is enol content directly proportional to stability of the enol. Which enol is more stable means that is enol content is more. Clear? Done? ఆల్ఫా హైడ్రోజన్ మీన్స్ డబుల్ బాండ్ పక్కన ఉన్న కార్బన్స్ని ఆల్ఫా కార్బన్ అంటాం. దీనికి ఉన్న హైడ్రోజన్స్ని ఆల్ఫా హైడ్రోజన్స్ అంటాం. ఫర్ ఎగ్జాంపుల్ CH2 డబుల్ బాండ్ CH2, దీనికి ఆల్ఫా కార్బన్స్ లేవు, 0 ఆల్ఫా హైడ్రోజన్స్, 0 alpha hydrogens. For example, CH2 H here is, so this is alpha carbon, double bond adjacent carbon. So how many hydrogens are there? 3 alpha hydrogens. అర్థమవుతుందా? CH3 CH double bond CH CH3. In this case, how many alpha hydrogens? How many alpha hydrogens? 3 3 6 alpha hydrogens. So more number of alpha hydrogens, compound is more stable. Okay, more number of alpha hydrogens, that alkene or the compound is more stable. అర్థమైందా? హలో హలో అడుగుతారు మళ్ళీ చెప్తే మళ్ళీ రెస్పాండ్ కారేంద్రా. మరి నేను మొత్తుకుంటున్నాడా? అడుగుతారు, అడిగినాక చెప్పిన తర్వాత మరి అర్థం కాలేదంటే మళ్ళీ చెప్తా కదా. కామ్గా ఉంటే ఏందన్నట్టు. క్వశ్చన్ అడిగినప్పుడు మళ్ళీ రెస్పాన్స్ ఇస్తే ఉంటుంది. ఏమన్నా యూట్యూబ్ క్లాసా? నా పాటికి నేను చెప్పుకుండా పోతానికి అంతేనా? కంప్లీటెడా? హలో So compare enol content in these 3 cases. Compare enol content. Compare enol content. Number 1, A, B, A, B, C. So let me know which enol content is more. So before the after first write the enol tautomer first, right, and compare it. Which is more stable? I told you that is more enolic content. Come on, do it. Right or wrong doesn't matter, you need to tell me the answer. అది యూట్యూబ్ స్ట్రీమ్ అవుతుందా? అరే అందరూ యూట్యూబ్ ఓపెన్ చేసి ఒకసారి గుడ్ ఈవినింగ్ లేకపోతే ఏదో ఒకటి ఆన్సర్ రాయండి. యూట్యూబ్లో ఆన్సర్ రాయండి చూద్దాం. హలో, ఐ విల్ క్రాస్ చెక్ ఇన్ యూట్యూబ్. అప్పుడు యూట్యూబ్ మనల్ని ప్రమోట్ చేస్తుంది. ఎంతమంది చూస్తున్నారు? వాట్ ఈస్ ద ఆన్సర్ ప్రణయ్? పిఏసి ఏసీ కీర్తన. కమాన్ అండ్ రిమైనింగ్ గైస్. దాంట్లో పెట్టావా? పర్లేదు. ప్రణయ్, ముకుంద్, ప్రణయ్ BCA. ఓకే, ప్రణయ్ కమన్. BCA అక్షిత, కమన్. మేఘన, డోంట్ నో. ABC, who is ABC? Who is ABC? Mukund. Okay, okay, come on. So write the Enol form and see its stability. So based on that, I am just asking important questions. These are. Come on, tell me the answer. Hello. So here is fifth one, right? Hydrogen. What we can get the answer? First this one. Second case, two things are possible. I'm just writing this one. More resonating structure is more stable. This is second one. And third one, yeah, these are the enol forms. Now in these three enols, which is more stable? You can see one important thing over here. What is the, in these three, we can see one important concept. What is that concept? One important concept we can observe here. What is that concept? Okay, by seeing these three compounds, you can observe one thing clearly. What is that? I'm expecting answer from any of. Very good. Right. So this is what? This is what, Nana? This is aromatic. This is non-aromatic. This is anti-aromatic. Anti-aromatic. Aromatic, non-aromatic, anti-aromatic. Now which is more stable? Generally stability order, which one, Nana? Aromatic compounds are more stable than non-aromatic. Non-aromatic, then anti-aromatic are more, right? Highly unstable. Aromatic are highly stable. Non-aromatic, okay, normal. Anti-aromatic means highly unstable. So now, obviously, this is this. So, what is the answer? A, B, C. A, B, C is the answer is right. Right. So the people who are not giving the answer, if you're like, like a YouTube streaming class, if you're attending like that, will ask. We actively participate in the classroom, right? We actively participate in the classroom. Okay. Hello. Classలోనా అర్జెంటా? కట్టేసినా కట్టలేదు అనుకుంటారా? 600 ఏదో ఉన్నట్టుంది, చూద్దాం అవ్వను, నేను చెప్తా. Anybody having any doubt in this case? 5 star పెట్టుకుంటాం. This is a 5 star question. 5 star means what? Not chocolate. Important. అరే 5 star చాక్లెట్స్ వస్తున్నాయి, తగ్గినట్టు ఉంటాయి. ఎక్కువ ఇది డైరీ మిల్క్ వస్తున్నట్టు. ఎక్కువ ఎవరు తింటున్నారు? డైరీ మిల్క్ 5 star? 5-star or dairy milk? Down, huh? Milk something is coming, right? Because a lot of students, their birthdays now, they used to give me 150 rupees chocolate, 200 rupees. Nowadays, nobody is giving. Conjuice. Hmm? So tell me in these two cases, no, which enol content is most A and B. Come on, which enol content is more? Today's class is very important for mains, BITSAT, advanced, NEET, MSET, JOB exam. Right? Don't be rush. So think something clearly and follow the class. It's easy. So tell me the answer. A. Who is A? Okay. Come on. Tell the answer and tell your name. The people who are giving the answers, whether right or wrong, doesn't matter. I just need an answer. Okay. If your answer is right, you should be very happy. If your answer is wrong, you should be very more happy because we learned something. We need to do the mistakes. So who is our best teacher means our last mistake. How many mistakes you did that particular day, right? So that many new things learned that particular day. If you didn't do any mistakes, because already whatever you know, right? When generally when we are not doing the mistakes, we are perfect in this particular case. For example, in my beginning my career, I could not stand like this and I could not speak like you, like I'm just shivering and what because we did a lot of mistakes and right now I'm confidently facing the camera. I'm just speaking with the camera right now, even though students are here, right? It is habituated. So the thing is, we need to do the mistakes. Mistakes are good. Not in the exam. Of course, in the mock test, it's good, but not in the final test. So don't, in the final exams are told that mistakes are good means don't do all mistakes and come back. So don't do like that. So whenever I'm asking, take the opportunity and tell me the answer. Okay? Don't sit ideally like a YouTube class or like a something online class. Here I'm giving the opportunity to you people to, right? Because when you are telling, you are involving in the classroom. So this is class for you, right? I'm not teaching for myself. Okay, come on. When I'm asking the question that is right or wrong doesn't matter. And one more important thing, if you don't know, just think something, guess, according to me, might be this could be the answer, according to me. So if it is right, okay, whatever I'm thinking is right. If it is wrong, oh, whatever I'm thinking is wrong. So the thinking needs, right? Education means not learning the facts, right? Education means how we are thinking towards a problem. Try to understand. And whenever asking the question, please do respond. If possible, do respond in the YouTube. Okay? It will be appreciated because our channel, right? It's a baby channel, a kid, Tota kid. We need to grow day by day, day by day. I need your help. You can share this video link to someone, some of your students, friends, not students, of course. At least we need to reach 1K subscribers. That is our goal. But we in 1 month, actually today 26th, right? Exactly 1 month completed, 242 subscribers reached a month, 242, 243, 243. So the second month might be, next target would be 500 if you people will cooperate. Otherwise, tell me the answer. Option B. Who? Good. I'll appreciate your answers. Right or wrong doesn't matter. I told you right is right. Yeah. B. Okay. Akshita B. So first enol content. First write the enol structure and see the enol stability. If enol stable, if enol is more stable, that is more enol content. So first write the enol and see its stability. I got only 3 answers. Meghna? Who? Hamsini? Hamsini? Yeah, Hamsini B. Good. Come on, faster. Right? If you don't know the answer, think something by your previous knowledge. Apply it. According to me, this would be the answer. According to me. Might be made correct or not, that doesn't matter, right? Yeah. Oh, I got only 4 answers. C. Okay. Who? Okay. Come on. I'll appreciate your answers. I'm not expecting any right answer. I just need an answer. Try to understand why I'm just, don't sit ideally and listen the class. It's not a movie. Right? Movie ki poyinam anukondi చూడొచ్చు అట్లనే. Not a movie, right? నాకు అవసరం లేదు, నా పాటికి నేను చెప్పుకుంటూ వెళ్ళిపోమంటే వెళ్ళిపోతా. టపా ఇది మోర్ స్టేబుల్, దిస్ ఈజ్ మోర్ స్టేబుల్, దిస్ ఈజ్ మోర్ స్టేబుల్, కథం సిలబస్ అయిపోయిందని చెప్పేస్తా. రైట్? దిస్ విచ్ I can do. But see, Nana, particularly in this case, first write the resonating structures, means enol form. CH3, CH2, CH, double bond, COH. H. This is the enol form, right? For write this one, CH2, double bond, CH, CH, double bond, COH, H. Now, in these two cases, which is more stable? Which is more stable? So here is, you are asking the question, that is alpha hydrogens or resonance. Always remember, resonance is more stable than the hyperconjugation, than the inductive effect. Right? Rolls-Royce, Honda City, Indica. Okay? Rolls-Royce, Honda City, Indica. Which is more enol content? Enol form. Keto Enol Tautomerism, what I am speaking, which is more enol form. So what is the answer right now? Hello? Obviously it is resonance stabilized. Hello? It is resonance is there. In this case, resonance is missing. Okay? So this is more. B greater than A. Okay now? Any doubts? Just think something. Important questions which I am trying to give you. Write it down. Done? Next question. Right, this is keto form. This keto form. I'm only writing the enol form for this. Now let me know which keto form is more stable or enol form is more stable in this particular case. This is keto form, enol form. Yeah, let me know. Let me know the answer. Keto form is more stable or enol form? Enol. Okay. Enol. Keto. Megna? Get idea, sir G. Enol. Online guys. Oh, online guys. YouTube లో stream అయితే లైక్ కొట్టి కామెంట్ కొట్టు ఆన్సర్ రాయ అందులో నువ్వు కూడా యూట్యూబ్లో ఆన్సర్ రాయి రాస్తున్నారా యూట్యూబ్లో ఆన్సర్ రాస్తున్నారా హలో యూట్యూబ్ ఓపెన్ చేసి దాంట్లో ఆన్సర్ రాయండి కమాన్ అడిగినప్పుడు చెప్తే ఆన్సర్ చెప్తే వుడ్ బి వెరీ హ్యాపీ నాకు ఎంకరేజింగ్ ఉంటుంది నా పాటికి నేనే చెప్పుకుంటూ పోమంటే समझ में आ रहा है मैं जब ये तेलुगु में बात कर रहे तो कॉन्टेक्स्ट के हिसाब से बोल दो मेरे को प्रॉब्लम नहीं हिंदी में सब लोगों को हिंदी आते मेरे को भी हिंदी आता मैं भी हिंदी बात कर सकता चल कमान बोलो भाई प्यारा बच्चा हिंदी ले उतर गए लो hello come on please tell me the answer keto form is more stable or enol form it is obviously enol form is more stable because in this case 6-membered cyclic ring is forming 1 2 3 4 5 6-membered right here is enol write one statement in this case enol form is more stable enol form is highly stable highly stable because point number 1 is forming 6-membered cyclic ring forming 6-membered cyclic ring and hydrogen bonding is also possible hydrogen bonding H bonding hydrogen bonding is also possible so in this case what enol form is more stable than keto form come on write it down fast నాలో నుంచి వస్తలే చదువుతున్నావు రివైజ్ చేస్తున్నావు వస్తున్నాయి మార్కులు. టాపిక్స్ ఆల్మోస్ట్ అయిపోయినట్టుగా. ఎలక్ట్రోకెమిస్ట్రీ 2 పాయింట్స్, కోఆర్డినేషన్ ఈరోజు అయిపోతుంది. ఎస్సీ 50 ఐసోమరిస్. హలో హలో, ఎనీ డౌట్స్ ఎనీబడి? When you have the option to ask the doubts, you can ask. Done? Right. Compare these three stabilities. Which enol form is more stable? Option A, option B, yeah, A, B, C, which I am giving. Which enol percent is more stable? Compare it, A, B, C. This is aldehyde. This is aldehyde and ketone. 2 ketones. Come on, tell me the answer. Right or wrong doesn't matter. Don't buy hard. So don't, right? Say the random answers. Think something. So I keep on telling, apply GOC concepts. Apply GOC concept and tell me the answer. EBA. Okay. Remaining guys. Which enol content is more stable? EAB, okay. Any other answers? Here, for example, Stability of enol content, right? In basic medium, which I'm asking. Basic medium. In basic medium, what exactly happens, Nana? So first, it obstructs the proton, right? If it is obstructing the protons, what we will get here? Carbon ion, right? Right? On the basis of carbon ion, tell me. On the basis of carbon ion. Carbon ion, so there is hydrogen, right? In this case, one methyl group. Methyl group is what? Which nature? Plus H and plus I, of course. Here is plus plus I. Here is plus I. Here is also plus I. So now, the resonance alkenes తో ఉన్నప్పుడు ఈ డబుల్ బాండ్ ఓకే అవ్వదు. Right. Plus it is 2 plus I. Here is 1 plus I. Right. So now, which carbon ion is more stable? Which carbon? Carbon ion stability what, Nana? Carbon ion stability. Carbon ion stability directly proportional to minus M, minus H, minus I. Yes or no? Carbon ion stability is inversely proportional to plus M, plus H, plus I. So now, which carbon ion is more stable? Right? So enol content in this case 1, 2, 3. Means ABC. Sorry. Because it is plus I is increasing, right? Yeah, write it down. Plus తీసుకున్నదే వస్తుంది ఇక్కడ ఒక ప్లస్ వచ్చేస్తుంది. Done? Clear? Hello? Yeah, shall I move? Write one more question. This is one option A. Option. Tell me which enol content is more. Come on. Second question. Question number 1. Question number. Come on, do it. A and B. A and B. Yeah, 3 questions. Come on, do it. ఇంతకుముందు ఒక రీల్ పెట్టేస్తే వచ్చినాయి కదా మనకి 3.9K వ్యూస్ వచ్చినాయి. ఈరోజు పెట్టింది అయితే lot of students failing because of this. For 1 minute or 2 minutes, we just started scrolling. What happens? Generally, if we want to do hard work and if we want to put our efforts for study and all, our brain won't accept. For instance, scrolling is they're not putting any efforts. Someone did hard work, they are just putting the videos in the Instagram and Facebook. What we are just doing simply scroll. When we are scrolling, what happens? High level of dopamine will release in our brain and it's a happy hour. When we are back to the studies, what exactly happens? That much of dopamine is not releasing. So there is no, we need to study, no concentration is because of this. So turn off notifications and keep phone away. Physical distance, because don't keep aside. Just so focus like a topper, so then only that's you. Zero distraction mode. రోజు పెరుగుతా ఉంది. రోజు మనం చేస్తున్నాం కదా, పని చేస్తున్నాం. So what is the first answer? BRA. So based on carbanion stability, let me know. Based on carbanion, because a lot of people are confusing. In this case, example, it is a carbanion. What wrong? A or B? What is the answer, Nana? Hello. Bina. Carbanion stability, right? C double bond O is group, which group? Withdrawing groups, right? Here is one methyl group is there. Then afterwards this one. A. Then B. Next, second one. So pH consider is minus I. Minus I. This is plus I. Plus I. Tell me. Tell me the answer. A or B? Second case. B. Clearly telling. In this case, This is plus I. Nothing. So what is A or B? Hmm? A. Write it down. So a lot of people are confusing in this particular case. Okay. Actually, experimental data is there. Based on experimental data we need to do, but this is the easiest way we can solve the question. Come on. Then, hello. Write one more option. This one. Come on. Tell me the answer. A, B. Okay. Come on, tell me the answer. Hmm. What is the answer? Hello. Obviously plus I, A, B, A, B, C. Write it down. Why A, B, C? This plus I, plus I, plus I, this plus M, plus M, plus M. Come on. So here is write one more point directly. Diketo, diketo, diketo is more enol content than keto ester, keto ester, then diketo, keto ester, ketone, ketone ester. This is a enol content. So if sometimes if they are given, just follow this order: diketo, keto ester, ketone ester. So in this case, a lot of reasons, resonance energy. For in case of ester, the enol form is very, very less because in the resonance energy is high. For example, write a question. Ketone like this, and this is. So tell me, this is ketone, this is ester. So which is more? Hello. A. Good. Next is the question. OET. Come on, tell me. A. So next question. Completed? Hello. This keto form, enol form. Let me know which is more stable. Very, very important question. Try to understand, right? This is particularly existing as like this. How? How it is existing? OH, O minus, positive charge here, positive charge. So means particularly try to understand. This is the structure. Is this compound, right? This is aromatic, right? Yes or no? Right? Keto form or enol form means obviously enol form. In this particular case, enol form is more stable because aromatic. Very important. Done? Hello. Done. Next, last question today. So now let me know. Two types of enol contents are possible right here. For example, if it is going left side, CH, C double bond O, OET. Right side, C double bond O, CH, double bond OH, OET. Now let me know which is more stable, which is possible in these two cases. Very, very important. This is also. So particularly here we need to understand in case of ester already resonance is there. Already resonating stabilized is, but it is somewhat free. So means after losing this one, right? This side is not happening now. Okay, because already it is having the resonance. But in this case, it is possible. It is okay, green signal. So write it down. Very important. So because already resonating structure, it is having the resonating structure. Come on. This is right. This is no. Okay, now? Then last one, last question. Last question. pH means what? Phenol. Yeah. Right now, in these two cases, this keto form, this enol form. Let me know which enol form is more stable. Which enol form? I told you there is what, which ring is forming? 6-membered. Whenever the 6-membered ring is forming, 6-membered cyclic ring, and intramolecular intramolecular hydrogen bonding and its resonance energy term. So here is enol content is 100%. Enol content is 100%. Write it down. Enol content, keto enol. So which is most enol content is 100%. Example. ఇవి అడ్వాన్స్లో చెప్తాను. లెవెల్ అంటే అడ్వాన్స్ చెప్దామని ఆపిన. If you know this much of resonating hyperconjugation, sorry, what tautomerism, whatever we discussed today. Once again, I'll explain. So today we started with this one, dyad system, triad system, keto form, enol form. So even different enol forms are possible. So this is space 1 pi 1 5. I already told you. This is also 1 5. In this case 1 5 is not possible because we didn't have any fifth position alpha hydrogen, because even though it is sp3 carbon, so we didn't have that. And in this case also it's not possible. In this case also enol not possible. Okay, because no alpha hydrogens, it's possible. Next, we can remove the alpha hydrogen from here and here. So major one, this is the right side one, because more number of alpha hydrogen. And this is a mechanism. This is base catalyzed mechanism, acid catalyzed mechanism. In base catalyzed mechanism, what we did, first the base is obstruct the proton, negative charge is forming. Already basically in GOC we are discussing that. So if the negative charge present at oxygen atom, that is more stable, so then proton, water is giving the proton, so we'll get this. This is base catalyzed. When in case of acid catalyzed, acid is giving this one. So simply both I already explained. And percent of enol content, in this case keto form, enol form cases, so C double bond O, bond energy is more. So that's the reason, right? Here is keto form is more stable. This is keto form is more stable than the enol form, right? In these two cases, which is keto form, enol form is more stable, means first we need to see the enol form. Enol content is directly proportional to stability of enol. More stable enol content, obviously that is more enol form. So in this case, more number of alpha hydrogens, so that is more stable. In this case, generally enol forms, no, enol content, it is aromatic, this is non-aromatic and anti-aromatic. Obviously aromatic is more stable than non-aromatic and anti-aromatic. Next, in this case, no, so enol content, here is the enol content is more stable because resonance stabilized. In this case, hyperconjugation is there, but resonance stabilized is more. Resonance, then hyperconjugation, then inductive effect. Wherever you go, so this resonance and hyperconjugation inductive effect will follows you until unless if you are not good at this. So go back and revise the GOC, inductive effect, mesomeric effect, hyperconjugation. Next, in these two cases, so it is enol form is more, because forming the cyclic ring and intramolecular hydrogen bonding. In this case, when we are comparing, so we are comparing on the basis of, right, on the basis of negative charge. So already I told you carbon ion stability. Here is also same thing. There is aromatic case. In case of esters, esters are more resonance stabilized. So because in the tautomerism is not possible. And this is the order, keto form and enol form here, right? I told you, yeah, diketones, ketoester, ketone, ester, right? This is all about the tautomerism, and some more 1 to couple of questions are there. Those things I'll explain in advanced classes, right? Thank you. Now the 11th class guys, you can leave, and right now I'll continue the coordination compound. Last class we were discussing VBT, right? I'll continue that VBT and we'll go with the CFT. So 11th class guys, any are there, so you can leave, please. Yeah. Zero distraction mode. This is one of the important thing. Lot of students failing because of this. For 1 minute or 2 minutes, we just started scrolling. What happens? Generally, if we want to do some hard work and if we want to put our efforts for study and all, our brain won't accept. For example, scrolling is they're not putting any efforts. Someone did hard work, they are just putting the videos in the Instagram and Facebook. What we are just doing simply scrolling. When we are scrolling, what happens? High level of dopamine will release in our brain, and it's a happy hour. When we are back to the studies, what exactly happens? That much of dopamine is not releasing, so there is no more. But we need to study. No concentration is coming because of this. So turn off notifications and keep phone away. Physical distance, because don't keep aside. Just focus like a topper. So then only you'll achieve. So zero distraction. .9 చూసారా ఎట్లే అచ్చా 3.9K. యాక్చువల్లీ ఇంకోటి తెలుసా, నేను ఈరోజు ఇంతకుముందు వాటికి ఇది ఉంది కదా, ఇది చూసేసరికి చాలామంది ఈరోజు ఏం చేపిస్తారు, డైరెక్ట్ పెట్టించారు. నీకు వాళ్ళది అటెన్షన్ 1 సెకండే ఉంటుంది స్పాన్, అది ఇది వచ్చేసరికి వాళ్ళకి వెళ్ళిపోతుంది. సో చెప్పిన మొత్తం అది రావడానికి మనకున్న ఈ స్క్రోల్ చేసేటోళ్ళు ఈ సబ్స్క్రైబర్స్ ఎక్కువ ఇచ్చారు, దానివల్ల 240 ఉండే ఈరోజు. యాక్చువల్లీ ఇది బాగుంది కదా వెనక బ్యాక్గ్రౌండ్ ఇట్లా. జనరల్గా ఇట్లా ఈ టైప్లో ఎవరు చేయరు అనుకుంటా. మామూలుగా అందరూ ఏదో పెడతారు కానీ మనకు బ్యాక్గ్రౌండే ఎడిటింగ్స్ వస్తున్నాయి. డబుల్ ధమాకా ఉంది కదా.
Students meaning because 1 minute or 2 minutes just we started. What happens generally, if we want to do some hard work and if we want to put our efforts for study and all, our brain won't accept. For example, scrolling is they're not putting any of
లాస్ట్ క్లాస్ ఏందా లిమిటేషన్స్ కదా. Yes, Nana. Hello. Hello. Is it audible? Hello. 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 Online guys. Come back. Come back. Come back. Is it audible, right? Yeah. So this is one of the important example we'll do in the VBT. CuNH3, right? Let me know everyone. Cu. This is somewhat exceptional case, no? CuNH3 taken for 2 plus. 2 plus. So let me know its hybridization, unpaired electrons and all. So do by yourself. Come on. Yeah, yesterday last class you did, right? VBT total మన యూట్యూబ్లో ఉంటుంది, స్ట్రీమింగ్ ఉంటుంది. తర్వాత నన్ను చూడొచ్చు కదా, ఫాస్ట్ ఫార్వర్డ్ పెట్టుకోండి. నేను ఏం చెప్పాను VBTలో, ఫర్ ఎగ్జాంపుల్ K4FeCN6 is there. So first we need to find out the iron oxidation state. What is the iron oxidation state here? X minus 6 is equals to minus 4, means X is equals to plus 2. Generally iron 26, right? Argon 4s2 3d6, but plus 2 means where we need to remove the electrons? Fe plus 2. Argon 4s0 3d6 means 6 electrons are here. 1 2 3 4 5, right? 1 2 3 4 5 6. But this is cyanide. I told you it's a strong field ligand. Strong field ligand. When the strong field ligand is there, pairing is takes place. So pairing is takes place means what? Right? So here is what happens. T2 sp3 they'll undergo. T2 sp3. Low spin complex, inner orbital complex, no unpaired electrons. It is a diamagnetic. Magnetic momentum equals to 0. Under root 4 into mu is equals to under 4 into 4 plus 2. So this is the way which we need to do. So already we did a number of questions. Just go back, see that video, and now everyone do this. Right or wrong doesn't matter. And everyone just open the YouTube. Please just let me know the hybridization. Type in the comments in YouTube, not in Zoom. Right or wrong doesn't matter. Just go to the YouTube. Hello. Right, type in the YouTube, right? DSP2, whatever it may be, I'll explain. Just go to the YouTube and type over there. Type in the DSP2, whatever it may be, I'll explain. Just and type there. Type in the DSP2, whatever it may be, I'll explain. Just and type there. Type in the only one is watching. ఒకటి రీల్ పెట్టాను నా దీంట్లో ఈరోజు. ఒకసారి వెళ్ళి లైక్ చేయండి దాన్ని. హలో, యూట్యూబ్లో ఒకటి రీల్ పెట్టాను మంచిది. సో మామూలుగా డోపమైన్ అది మొబైల్ ఎట్లా. ఓకే, done. So what about this answer? What is copper oxidation state here? Yeah. Right. What is the copper oxidation state now? Copper Cu 2 plus. What is copper atomic number? 29. Argon 4s1 3d10. So what exactly happens here? Copper 2 plus means s0. So 3d9. Right now 1 2 3 4 5 6 7 8 9. 9. So here is right now. We'll think that it is a pairing is not possible. So we'll think that this is sp3 tetrahedral structure, right? But Pauling told that, it is a square planar structure. Experimentally they determined that. What? So square planar, this is tetrahedral is wrong, so he told that what? Square planar structure is right. Square planar structure is right. But how the square planar? So then he thought that what he did, square planar means what? dsp2, right? Hello. So what he explained, according to Pauling, he told that this electron is jumping to here. Okay, so this electron is promoting to here. So now it is vacant, right? So now here this is undergoes what? dsp2 square planar. Yes or no? Square planar. Who explained this is Pauling. So now this is what? 3d 4s 4p, right? So now again came Pauling, you told right, correct. Okay, I'll agree with you. but this is electron is what? In the outermost. We can easily remove this electron, means this total complex can easily undergo oxidation, right? Hello. So this complex can undergo oxidation. Why it undergoes oxidation? Because valence electron is there, right? Cu NH3 taken 4 2 plus, if undergoing the oxidation means removing the electron. So what exactly happens? Cu NH3 taken 4 3 plus now. But what exactly happening? This is not undergoing oxidation. It's not undergoing oxidation. Means electron is not in 4p. Something is fishy, right? According to that concept, not sp3. According to Pauling, it is a square planar. But the problem with that electron. So next, what he did, he told, electron is at here only. Where? At 3D only. 3D only. But the hybridization is going like this. He explained. So he explained this is somewhat exceptional case. This undergoes sp2 sp2d sp2d, right? dsp2 or sp2d, right? So electron is here only, right? dsp2 square planar complex, he explained. Come on, write it down. So this complex, which type of means sp2d. Experimental ga. Diamagnetic or paramagnetic ra? Paramagnetic, because unpaired electron is present. That one. Write one more question, ra. Write a question. The spin only magnetic moment value of the spin only magnetic moment value of the spin only magnetic moment value of BR value of Mn BR 4 2 minus ion is 5.9 pm. 5.9 pm. On the basis of VBT, predict the hybridization and geometry is a question. Come on, do it. Let me know the hybridization geometry. Write the hybridization in the YouTube. Just open the YouTube, just is a live is going on. Write your hybridization over there. YouTube. Weak. So means what we need to understand in this case, what is the, because by seeing this question, M and B are 4. 4 means what? Either it would be tetrahedral or square planar. Either it would be tetrahedral or square planar. But he gave this BM, 5.9 BM. So means what? How many unpaid electrons are present? How many unpaid electrons are? 5 unpaid electrons. So 5 unpaid electrons should present. So means manganese. What is the manganese atomic number? Manganese atomic number 25. 25 means argon 4s2 3d5. So what is the oxidation state? Right, plus 2. Plus 2 means what? Mn2 plus 4s0 3d5. So means what? 3d5 1 2 3 4 5 1 2 3 5, right? And यहाँ पे undergoes sp3 hybridization. So now this is tetrahedral. According to the concept which is given us 5.9 bm. What is 5.9 bm? Means 5 unpaired electrons, means it's matching. Obviously this is a tetrahedral geometry. sp3 hybridization and tetrahedral geometry. Imagine if you are confusing, sir, might be if it is undergoing strong field ligand, right? If it is pairing is takes place, what exactly happens? How many electrons? 5, right? 1 2 3 4 5 ये ओला हो गए, right? For example, if it is dsp2, right? So magnetic moment is 1.8 something bm, right? It's wrong. Not a square planar, it is a tetrahedral geometry. Clear everyone? समझ में आ रहा है ना? Hello. Hello. अब्दुल है क्या? सुन रहे ना? చెప్పనా? ఈ క్వశ్చనా ప్రీవియస్ క్వశ్చనా? ఇది ఫస్ట్ కాంప్లెక్స్లో ఫస్ట్ Cu2 ప్లస్, రైట్? కాపర్ 29 4s1 3d10 కనిపిస్తుంది అబౌట్. సో అప్పుడు 2 ప్లస్ అంటే ఎలక్ట్రాన్స్ 4s నుంచి ఒకటి 3d నుంచి ఒకటి తీసేస్తాం. అప్పుడు 3d9 అయింది. 9 ఉన్నాయి ఇక్కడ. 9 అంటే ఇక్కడ యాక్చువల్గా ఏంటంటే ఫస్ట్ sp3 హైబ్రిడ్ వస్తుందని అనుకున్నాం. sp3 టెట్రాహైడ్రల్ అని చెప్పేసినాం. కానీ అప్పుడు ఎవరైనా పౌలింగ్ వచ్చిండు. పౌలింగ్ వచ్చి దీన్ని ఎక్స్పెరిమెంటల్గా చూసిండు. చూసి అరే ఇది టెట్రాహైడ్రల్ కాదు, స్క్వేర్ ప్లేనర్ అని చెప్పిండు. ఎవరు? పౌలింగ్. స్క్వేర్ ప్లేనర్ అంటే ఇట్లా dsp2 అని ఓకే, ఇది ఓకే అనుకున్నాం. మరి అప్పుడు అయితే ఆయన ఏం చెప్పిండంటే ఇక్కడ 3Dలో ఉన్న ఎలక్ట్రాన్ ఉంది కదా, అది 4Pలోకి మైగ్రేట్ అవుతుంది అని చెప్పిండు. అంటే అవుటర్ మోస్ట్కి వెళ్ళిపోతుంది అని చెప్పిండు. అప్పుడు ఏంటంటే మరి అవుటర్ మోస్ట్ ఎలక్ట్రాన్ బయట ఉన్నప్పుడు వీ కెన్ ఈజీగా అది ఆక్సిడైజ్ అవ్వాలి కదా, అంటే ఈజీగా ఒక ఎలక్ట్రాన్ లూజ్ అవ్వాలా, రైట్? ఆ ఎలక్ట్రాన్ లూజ్ అవుతలేదు. అంటే స్క్వేర్ ప్లేనరే మరి నువ్వు చెప్పింది కరెక్టే, కానీ మరి ఇక్కడ ఆ ఎలక్ట్రాన్ అనేది బయటికి రావట్లేదు. అంటే మళ్ళీ ఎవరు హగ్గిన్ అనే ఇంకో సైంటిస్ట్ ఏం చేసిందంటే, పౌలింగ్ నువ్వు చెప్పింది రాంగ్ అయ్యా, స్క్వేర్ ప్లేనర్ ఓకే కానీ రైట్ ఈ ఎలక్ట్రాన్ 3Dలోనే ఉంటుంది, అంటే లోపల ఇన్నర్ ఆర్బిటల్, వీ కాంట్ రిమూవ్ దిస్ ఎలక్ట్రాన్. 3Dలో ఉంటుంది, ఇది 3D నానా, 3Dలో ఉన్నదాన్ని మనం తీయలేము, ఎందుకంటే ఇన్నర్లో మనం ఎప్పుడైనా విచ్ ఎలక్ట్రాన్ వీ కెన్ రిమూవ్? అవుటర్ మోస్ట్ ఎలక్ట్రాన్, వీ కెన్ రిమూవ్ ద అవుటర్ మోస్ట్ ఎలక్ట్రాన్ కదా, కానీ అది 3Dలో ఉన్నప్పుడు మనం తీయలేము. అప్పుడు కొత్త హైబ్రిడైజేషన్ ఏం చెప్పిండంటే sp2d ఇది అవుతుంది అని చెప్పిండు. మనకు ఇలా అవుతే sp2d అయితే ఈ ఎలక్ట్రాన్ని మనం తీయలేము. స్క్వేర్ ప్లేనర్ ఉంటుంది, ఆ ఎలక్ట్రాన్స్ అది ఆక్సిడైజ్ అవ్వట్లేదు. ఎక్సెప్షనల్ కేస్ ఇది, ఎక్సెప్షనల్. అంటే దీంట్లో వీబీటీలో లాట్ ఆఫ్ ఎక్సెప్షన్స్ ఉన్నాయిరా, రైట్? ఇవి ఎన్ని ఎక్సెప్షన్స్ తోటి అంటే మనకు తలకే తిరిగిపోతుంది కాబట్టి, సో మళ్ళీ ఇంకో థియరీకి వెళ్ళిపోతాం. దట్ ఈస్ నథింగ్ బట్ క్రిస్టల్ ఫీల్డ్ థియరీ. ఓకేనా? రైట్, వన్ మోర్ క్వశ్చన్. Predict the number of unpaired electrons in square planar PtCl4 2-. Predict the right now. Predict the number of unpaired electrons in. Predict the number of unpaired electrons. Number of unpaired electrons. Predict the number of unpaired electrons in square planar complex. Square planar complex of PtCl4 2- ion. PtCl4 2- ion. Platinum atomic number ఎంత? నేనే అడిగితే నువ్వు నన్ను అడుగుతున్నావు ఏందన్నా? 58. కొన్ని ఇస్తారు, కొన్నిసార్లు ఇస్తారు, కొన్నిసార్లు ఇయ్యరు. ఇది 5d8 6s2 ఉంటుంది అవుటర్ మోస్ట్ ఎలక్ట్రాన్. 5d8 6s2. ద ప్లాటినం 2 ప్లస్ ఎంత? 5d8 6s 0. So here is 5d8 is there. Come on, do it. Like here, I'm only telling this is a square planar complex, right? So here I'm only telling how many unpaired electrons? 1 2 3 7 right? Square planar complex I so what it would be the hybridization? DsP2. But chlorine is which field ligand? Weak field ligand. So then sp3 tetrahedral, but it is square planar, right? But exactly what happening, this is in VBT lot of exceptions are there, right? This is the exception of hello this is the exceptional losses. DsP2, no unpaired electrons. Exception గంట ఏదో ఉంటుంది కదరా, ఏదో సిరీస్ ఉంటుంది కదా, పోటర్ ఎక్సెప్షన్ వీబీటీలో లాట్ ఆఫ్ ఎక్సెప్షన్. ఇది రీల్ చేద్దాం, హిట్ అవుతుంది. ఇక్కడ Cl minus even though weak field ligand, Cl minus even though weak field ligand, exception. ప్లాటినం గుర్తుపెట్టుకో. కొన్ని గోల్డ్ సిల్వర్ గుర్తుపెట్టుకోరా. నెక్స్ట్ క్వశ్చన్ రా. Come on, do this. Tell me the diamagnetic number of unpaired electrons hybridization. టైప్ చేస్తున్నారా? హలో యూట్యూబ్లో NO2 -1. ఇది 3.9కే వచ్చి ఆగిపోయిందిరా. త్రీ 3.9 అంటే ఇప్పుడు ఒక 100 కదా. NO2 strong field ligand. Come on. NO2 strong field ligand. Hey, 4.2K రా. 4.2K బాగుపోతుంది రీల్. ఫస్ట్ టైం ఇది క్లిక్ అయింది. అన్ని రీల్స్లో అంతా ఫస్ట్ది అంత 1.5 ఒకటి ఉంది. అన్ని 478 7 4.2K పోయింది.
Zero distraction mode. This is one important thing. Lot of students.
అవునరా, అది ఆల్మోస్ట్ డ్రాప్స్లో ఉంది. రేపు కొంచెం లాస్ట్ రేటింగ్స్ ఉండే. అదే దాని గురించే.
Zero distraction mode. This is one important thing. Lot of students because of this. For 1 minute or 2 minutes, just we started. What happens? Generally, hard work, and if you want to put your efforts for study and all, brain won't accept. For instance, group is they're not putting any efforts. One did hard work, they are just putting the videos in the Instagram and Facebook. What we are just doing, when we are studying, what happens? High level of dopamine will release brain, and it's a happy hour. When back to the studies, what exactly happens? That much not releasing. We need to study. Concentration is because of. So turn off notifications and keep phone away. Distance. Don't keep aside. So take it proper. Then only that's you. Zero distance. Lot of students because zero distance.
దాంట్లో రీల్కి కింద ఏమైందా? కింద కామెంట్ పెట్టరా. అరే అందరూ మన షార్ట్ ఉంది కదా, షార్ట్కి ఈరోజు షార్ట్ పెట్టాను. నా స్టేటస్లో ఉంది చూడండి. లైక్ చేసి ఒక కామెంట్ పెట్టండి అందరూ. రైట్, వాట్ ఈస్ కోబాల్ట్? కోబాల్ట్, కోబాల్ట్ అటామిక్ నెంబర్ 27. ఆర్గాన్ 4s2 3d7. Argon 4s2 3d7. What is cobalt 3 plus? Right, NO2 minus cobalt 3 plus. No? So 3d6. एक दो तीन चार पाँच. How many electrons? 6. एक दो तीन चार पाँच 6. Right, I told you. What I told? NO2 is a strong field ligand. Yes or no? So what exactly happens, Nana? Pairing is takes place. एक दो तीन चार. So D2 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 sp3. So diamagnetic or paramagnetic? Dia. Magnetic moment equals to 0. Right? Inner orbital complex. Inner orbital complex or low spin complex. Or low spin complex. I told you. D2 sp3 inner orbital or low spin complex. sp3 D2. Hello. Higher orbital complex. Higher orbital complex or high spin complex. High spin complex. Higher orbital, high spin complex. Clear? Hello. Done? If any complex is coming, so you need to, you are ready to do. Okay now? Fe F6 3 minus, do it. Fe F6 3 minus. And do it fast. Because coordination compounds don't take the chance, because in inorganic chemistry, whatever the question is coming, so this is important area, Nana. हाँ completed. How many sp3d2, how many? Iron. What is iron? 20, 26. Argon 4s2 3d6. Obviously plus 3, right? Plus 3 means 3d 5. I'm directly writing 2 electrons from here and 1 electron from here, right? 1 2 3 4 5, 1 2 3 4 5, right? So this is weak field ligand. So sp3d2, sp3d2, yes or no? Got it? So they'll ask which of the following, means we need to be very fast now. Okay now? Next question. Fe NO H2O taken 5 2 plus 2. Come on, do it. Hmm? Hmm. NO plus roti. NO plus. This NO is plus 1. Strong field ligand. Actually, this is compound is we are called as brown ring complex. Brown ring. Okay. Brown ring. Brown ring complex. రింగ్ వస్తుంది ఎన్ఓ ప్లస్ ఉందా లేదా అని అనాలిసిస్లో చేస్తాం. ఇక్కడ ఏంటి ఐరన్ కదా, ఐరన్ ఆక్సిడేషన్ స్టేట్ ఎంత వస్తుందో +1. ఐరన్ కోన్సా 26 +1 directly I am writing. Okay, 4s1 3d6. But here 2 3 4 bond, एक दो पांच 6 here, एक यहाँ पे एक 15 यहाँ पे 5. Okay, first write like this. This NO plus because of NO, this is pairing is takes place here. This is also one of the exceptional case, right? Because if it is coming here, so DSP2 is it's not sufficient. So means these 3 unpaired electrons are like that only. Two, three, four, five. sp3 d2 nana. sp3 d2. 3 unpaired electrons, 3 point something bm, 3 point something 8 bm, and outer orbital complex, paramagnetic. This complex NO is a brown ring complex. ఇదే కంటిన్యూ టీ స్టార్ట్ చేద్దాం. కొంచెం ఇంపార్టెంట్, ఆల్రెడీ ఎలక్ట్రోకెమిస్ట్రీలో మెయిన్ పోర్షన్ అయిపోయింది. నెక్స్ట్ NiNH3 take N6 2+. హలో, ఎస్ సార్. పర్లేదు సార్, పర్లేదు. 2 సార్. ఏదో 2 సార్, 2 చేస్తున్నాను సార్. అట్లా ఒకసారి ఇట్లా ఇప్పుడు స్ట్రీమింగ్ అవుతుంది. ఇప్పుడు స్ట్రీమింగ్ అవుతుంది, చూడొచ్చు మీరు. యూట్యూబ్ ఓపెన్ చేయండి నాది ఛానల్. యాక్చువల్గా ఇప్పుడు మీరు చూడండి, నేను లైవ్లో ఉంటాను. లైవ్లో ఉన్నాను. యాక్చువల్గా అది అయిపోయింది, వేరే చాప్టర్. నేను ఉన్నారు. అవును. 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 అది కొన్ని రోజులు మళ్ళీ అన్‌లిస్ట్ చేద్దాం. ఇప్పుడైతే ఫ్రీనే. ఎవరికైనా స్టూడెంట్స్‌కి షేర్ చేయరాదురి చూస్తారు. యాక్చువల్‌గా లైవ్‌లో ఉన్నాను. మీరు లైవ్‌లో చూడండి నేను కనిపిస్తా. వాట్ ఈస్ ఆన్సర్ నాన్న? హలో. sp3d2. In this case, ammonia acts as a weak field ligand. ఓకే. సో ఈ అమ్మోనియా తోటి కొంచెం చాలా తలకాయ నొప్పి ఉంటుంది. ఒకసారి ఏమో ఒకలా బిహేవ్ చేస్తుంది, ఇంకోసారి ఇంకోలా బిహేవ్ చేస్తుంది. రైట్. రైట్. హలో నిఖిల్, ఎంతరా? 28. ఆర్గాన్ 4s2 3d8. ఆర్గాన్ 4s2 3d8. సో obviously ni2 plus argon 4s0 3d8. Yes or no? Hello. Now 3d8 1 2 3 4 5 1 2 3 4 5 6 7 8, right? And right, what exactly happening here? D2 sp3 d2 sp3 d2, 2 unpaired electrons, 2 point something 7 or 8 bm, paramagnetic, so spin complex. Okay, because you need to practice while complex is in front of you. You should be very low. You should be, because that's the reason I'm just giving you n number of examples. Then write one more. Come on, do it. అవునండి, ఇంతకుముందు ఫోన్లో మాట్లాడింది యూట్యూబ్లో జూమ్లో మీట్ పెట్టా. ట్రై చేద్దాం. ఫోన్లో మాట్లాడింది వచ్చిందా? అదే యూట్యూబ్ స్ట్రీమింగ్లో జూమ్లో కంట్రోల్ చేసి కానీ యూట్యూబ్లో ఏనా అర్థం కాలే. అంటే ఫోన్ దగ్గర ఉంది కదా, కవర్ చేసినా ఇది వినేస్తుంది. అందుకోసం కొంచెం జాగ్రత్తనే మాట్లాడండి, ఏది పడుతుంది మాట. డన్. హలో, టైం తీసుకోకండి, ఫాస్ట్ చేయాలా. క్రోమియం ఎంతరా? 24 are gone. 4s1 3d5. 3 plus means what? 4s0 3d3. Imagine whenever the 3 electrons are there, whether it is from field or log, doesn't matter, right? Already 3 electrons here, 1 2 3. So simply T to sp3. T to sp. Write it down. Number of unpaired electrons 3 point something bm, 3.2 something bm. Okay now? Done now? TOF6 3 minus TOF6 3 minus. Come on, do it. Do this. The people who did this, then scandium F6, scandium F6 3 minus. సాయిరితికి రాలేదురా? అని ఏం చేస్తాం? కొట్టు పెట్టి రమ్మంటాం. స్ట్రీమ్ అవుతుంది కదా, చూసుకుంటారులే తర్వాత. Come on, do it. ఇవన్నీ హోంవర్క్ లాగా చేసేయండి. దేంట్లో రాది? ఎన్నైనారా నెంబరు? Is it confusing or easy, Ra? Hello? Huh? No. Confusing or easy? Water is weak field ligand. Water is weak field ligand. చాలా ఇంకేమన్నా? హలో? Will I change the page or continue here? Means this is practice, na? So when you are doing the practice, na? Huh? Hello. Hmm? ఎగ్జామ్లో క్వశ్చన్స్ తొందరగా అటెంప్ట్ చేయొచ్చు. నేను ఏదో కొన్ని ఎగ్జాంపుల్ చెప్తే మీరు మళ్ళీ ప్రాక్టీస్ చేయాలన్న ఉద్దేశంతో జస్ట్ గివింగ్ యూ ఆల్ దీస్ క్వశ్చన్స్. ఓకే. Okay, just do as a homework and I'll explain the answers in the next class. Okay. Hello. Right, one more important point, Nana, here. Hello. Hello. Write it down. Sometimes weak field ligands and రాసేసుకుంటారు. Weak field ligands. F minus Cl minus Br minus weak field ligand. F minus Br minus generally. OH minus H2O NH3. O3 minus etc. Strong field ligands. CO Cn minus NO NO plus NO2 minus PPH3 PF3 PR3 ఎక్కువ వాడం మనం బట్ జనరల్గా పాలిడెంటేట్స్ ఉంటాయి కదా కొన్ని పాలిడెంటేట్స్ మీన్స్ బైడెంటేట్ దోస్ ఆర్ ఆల్ కమ్స్ అండర్ సో జనరల్గా ఫర్ కోబాల్ట్ అండ్ క్రోమియం నోట్ అని పెట్టండి అనుకోండి ఫర్ కోబాల్ట్ అండ్ క్రోమియం కాంప్లెక్సెస్ ఫర్ కోబాల్ట్ అండ్ క్రోమియం కాంప్లెక్సెస్ cobalt chromium complex NH3 acts as a strong field ligand. Note for cobalt and chromium complexes for cobalt and chromium complexes for cobalt and chromium complexes NH3 acts as a strong field ligand. NH3 acts as a strong field ligand. Okay, first these many questions which I gave you. Still you people have the number of questions, but okay. Hello. So first go with the VBT this much of level. So then after you can upgrade by yourself, right? If everything if I am doing, it's not possible. Yes or no? The maximum which I can from one level, mains level, advanced level, some more questions also is there. I'm not giving that advanced level of questions. These are more than enough for the mains level, and particularly just go through the NCRT and whatever the complexes are there, first be perfect over there. This is the second level. Sir, this many ఫస్ట్ పై పైన ఇచ్చారు కాబట్టి ఫస్ట్ అది చదవండి, తర్వాత ఇది చదవండి. సో ఒకసారి పై పైన చదివిన తర్వాత యూ విల్ గెట్ అ లాట్ ఆఫ్ కాన్ఫిడెన్స్, రైట్? వాట్ ఇట్? హలో. Hmm? Screenshot తీసుకో. 1 2 5 6 9 10 11 13 14 15 18 19 22 23 24 25 28 29 30 31 32 40 41 ఇచ్చా. So next CFT. I hope a VBT is clear, right, everyone? Any doubts in VBT? Easy, right, VBT? Only the problem with weak field case, strong field case. Once we know that, and atomic numbers, if we know the oxidation state, we can solve any type of question. Hello, done? So CFT, crystal field theory. So it's a electrostatic model. Write it down. It is a electrostatic model. Electrostatic model. So means like according to CFT, it is a ionic bond type now. Ionic bond. Ionic bond. Electrostatic model. Done? Next, according to this electrostatic model, metal ligand bond is ionic, right? And it's a purely electrostatic interaction between metal and ligand. So write it down. I told you ionic bond, right? Ionic bond means what? Cation and anion is there, so electrostatic force of attractions are present in between them. ఏంటి? ఒక్కొక్క కాన్సెప్ట్ ఒక్కొక్కలా ఎక్స్ప్లెయిన్ చేస్తుంది. దిస్ CFT is somewhat different, right? So central metal atom is like acts as a positive charge. Ligands are negative charge. They are approaching to the central atom, right? So when central, it's a type of ionic type of bond. Done? Completed? TFT, BBT, CFT are most important. Most. Right? When ligands are anions, neutral molecules. When anions means we could say point charges. And the neutral molecules we could say point dipoles. Write it down. So point charges. When ligands are negative charge, point charges approach to central atom. In I told you d orbitals are two types, axial and non-axial. For tetrahedral case and octahedral cases in D block, when I'm explaining that time I explained, right? D block. $2.9K. ముందే కూడా తెలుసు కదా. Next, the transition metals that present at the central atom, the complex considered as positive point charges. Yes or no? Ligands are negative means ionic bond, ionic cation and anion. Anions are ligands. Cation should be CM. Transition metals that is present in the central atom. Right? Negative ions are approached to the central atom. Chandra? Yeah. Point charges. Metal is the positive, ligand is the negative. Ion-ion interactions. So this is metal is positive, this is dipole. If it is neutral. Huh? Arrow? నెగిటివ్ అదేరా ఇప్పుడు ఇక్కడ ఇది లీగల్ న్యూట్రల్ కదా పాజిటివ్ చార్జ్ ఉంది కాబట్టి ఇటు ఎలక్ట్రాన్స్ అనేవి అట్రాక్ట్ అవుతాయి నెగిటివ్ ఇవి ఇటు సైడ్ వచ్చేస్తాయి అయాన్ డైపోల్ అంటాం దిస్ ఈజ్ అయాన్ ఇన్ దిస్ కేస్ అయాన్ డైపోల్ ఓకే యాక్చువల్లీ న్యూట్రల్ మాలిక్యూల్కి ఏం చేస్తాం ఫర్ ఎగ్జాంపుల్ న్యూట్రల్ ఉందిరా అండ్ పాజిటివ్ అదేం చేస్తాం మనం ఆ నెగిటివ్ని అట్రాక్ట్ చేస్తాం అప్పుడు ఏమవుతుంది అది అయాన్ డైపోల్ అవుతుంది 2 పోల్స్ లాగా అవుతుంది రైట్ ఇట్ అవునరా ఎలక్ట్రాన్స్ అనేవి ఇటు సైడ్ వస్తాయి ఎందుకు పాజిటివ్ ఛార్జ్ ఇక్కడ ఉంది కాబట్టి డైపోల్ డైరెక్షన్ డిపెండ్స్ ఆన్ దాన్ని బట్టి ఉంటుంది ఫర్ ఎగ్జాంపుల్ హెచ్ఎఫ్ ఉందనుకో అది డిపెండ్స్ ఆన్ డిఫరెంట్ కేసెస్ ఇక్కడ ఇన్ దిస్ కేసు ఇలా రాస్తాం ఇక్కడ ఏమవుతుంది ఇక్కడ పాజిటివ్ ఛార్జ్ ఉంది ఇక్కడ ఇందులో పాజిటివ్ ఉంది నెగిటివ్ ఉంది రైట్ ఇప్పుడు ఏమవుతుంది నెగిటివ్ అనేది ఇటు సైడ్ వస్తుంది ఇటు మూమెంట్ అనేది ఇటు వస్తుంది అర్థమవుతుందా రైట్ రా ఇన్ ఐసోలేటెడ్ గ్యాసెస్ మెటల్ ion 5d orbitals are degenerate. Degenerate means what? Same energy. In isolated gas metal means in isolated cases the 5d orbitals are there dxy, dyz, dzx, dx square y square dz square all are degenerate. Degenerate means all are in the same energy. 1 2 3 4 5 all are in the same energy. Degenerate. Then degenerate orbitals and ఏంట్రా what is degenerate orbitals? Same energy. So orbitals that are identical in energy, right? Degenerate d orbitals, free metal atom or ion. And the free metal atom ion degenerate. So did you ever heard this degenerate? ఇంతకు ముందు విన్నారా ఎప్పుడైనా degenerate d orbitals, free metal atom and ion. మంచి బ్యూటిఫుల్ ఉంది కదా రీల్లీ లైక్ చేయండి రా ఎవరైతే ఉన్నారో లైక్ చేసి ఏదైనా కామెంట్ చేయండి 4.9 పోయింది కదా ఫస్ట్ టైం 5 అయిందా 5 వైరల్ స్టార్ట్ అయింది రో మనం కూడా ఒక అచీవ్మెంట్ కదా
This is one important thing. A lot of students failing because
ఒక్కటి పెరిగిందా? అంటే రీల్స్ వైరల్ అవుతూ ఉంటాయి. సరేనా? So this degeneracy still maintained in right spherically symmetrical field of ligands are surrounded by the metal atoms or ions. Assumptions. These are all assumptions in the CFT. If spherically symmetrical, the degeneracy is still maintained if spherically symmetrical field of ligand surrounds the metal atom or ion. Assumptions of CFT. అందరు పోతున్నారు, నలుగురే మిగిలారు. 9:30కే బోర్ కొట్టేసినాయి. బోర్ కొడుతున్నా, ఏం చేద్దాం మరి బోర్ కొట్టకుండా? జోకులు చెప్పనా? చాలా టైం 7:30 to 8:30 2 hours అవుతుంది. రైట్. Degenerate d orbitals of free metals. Average energy, overall average energy increased due to spherical field of ligands. రేపు కంటిన్యూ చేద్దామా, లేకపోతే సరే వెళ్ళిపోతున్నారు ఆల్మోస్ట్? అదే రేపు కంటిన్యూ చేద్దాం మరి. ఈ సిఎఫ్టీ రేపు కంప్లీట్ చేస్తాను. సిఎఫ్టీ, దెన్ ఈఏఎన్ నెంబర్ ఒకటి వస్తుంది అండ్ ఐసోమరిజం ఇవి చెప్పేస్తే ఆల్మోస్ట్ ఆల్. ఈలోపు మీరు అది ఉంది కదా వీబీటీ ప్రాక్టీస్ చేసుకునండి. సో వాట్ ఎవర్ ద డౌట్స్ ఆర్ దేర్ విచ్ ఐ గేవ్ దట్ 41 ఇచ్చాను కదా ఎగ్జాంపుల్స్, అవి నేను డిస్కస్ చేస్తాను టుమారో. ఓకేనా? అందులో డౌట్స్ ఉన్నాయో మీరు డిస్కస్ చేస్తాను, చేయగలుగుతారు. సొల్యూషన్స్ మీరు చేయండి, చేస్తే నేను ఆ సొల్యూషన్స్ మీకు ఫోటో తీసి పంపిస్తాను. ఎగ్జాము ఈరోజు కాదు, ఈరోజు ఫ్రైడే కదా, సండే రోజు రేపు పెడతా. రేపు క్లాస్ ఉంటుంది, సండే రోజు రాయండి. సండే రోజు కెమికల్ కైనెటిక్స్ పెడతాను అండ్ రైట్ విచ్ వన్ ఆర్గానిక్ కెమిస్ట్రీ, సొల్యూషన్స్, కెమికల్ కైనెటిక్స్, సొల్యూషన్స్, కెమికల్ కైనెటిక్స్ రెండు చదవండి. అయితే ఈ రెండు చాలు. కైనెటిక్స్ రెండు సండే పెడతాం. చలో, బాయ్ నాన్న.